welcome. Thank you so much for coming. We know it's the end of the day, but we're really, really excited to talk to you. We expect you've heard a little bit about Firestore, hopefully a little bit. But it's Firebase's newest database technology. We're really excited about it. And one of the things with Firestore is it's really massively scalable. And that's really, really exciting. But when you think about that in terms of the UI, that's a little stressful. Firestore is massively scalable, but sometimes the browser is not. And so this is Tim, and I'm Susan, and we've been building out the Firestore UI. And so, as I said, the Firestore is really, really scalable, and the UI needs to be scalable to handle that. And so what does that mean? We actually expect that maybe many of you haven't seen the UI, so we wanted to just show an image of what it looks like. So you can see in the leftmost panel, the collections are listed there. We've selected the collection demo. And then in the middle, we have a document selected, document 00005, classic document. And then sometimes as real-time data updates, you'll see the field updates. So maybe that's a user updating a value. And then if you're adding documents, it'll animate in green. And if you're changing or updating them, they're going to go orange.
Great. So there'll be 3 parts to this talk. So first, we're going to talk about how we modeled this data, how we mapped it and transformed it to get it into the UI. This massive, real-time stream of data coming from Firestore. And then secondly, once we've got that massive stream coming in, we want to restrict it and constrain it so that it still performs well in the UI. And then finally, once we've got all that set up, we want to add the Firebase real-time change visualizations to make it delightful.
So we have Firestore, which I like Firestore. We have that, but how do we actually get that data into our app? So we think that many of you probably familiar a little bit with the real-time database SDK. So in the real-time database SDK, here we're listening to items as a reference, and every time that a child is added or changed, we get an update. So that's an event-based system. So if there's 50 child added, we're going to get 50 of these events. And then internally in our code, we handle the state. So we call ref.on to listen to those changes. And then when we want to stop listening to them, we call ref.off. And that's really important because otherwise we're going to have some memory leaks in our code. So we need to call ref.off to make sure that our app stays performant.
So here's the Firestore equivalent of this. So we're listening to the collection items. We call ref.onSnapshot. So we can actually do, Firestore provides both the event view of the world through snapshot.docChanges. So this would be 50 added events if we had 50 items. Or you can do the state-based view of the world, which is snapshot.docs. So this is, at this point in time, what is the full state that you requested? So this is a little bit different to the real-time SDK in that in the real-time SDK, if you had 50 items, you would get 50 snapshots. In the Firestore SDK, you'll get the first snapshot of 50 items. So it's a little bit easier to work out what was my initial list and what are the changes after that. And then, of course, to unsubscribe, it's a little bit different. You get a method that you call to unsubscribe later on.
Cool. So now we have a way to get the data into the app. So Firestore is really, really scalable, and that's really exciting, but the events are coming in over time. So how do we actually model that information? I mean, what would be really great is if we could have everything as an array ahead of time. So something like this, we could have players with some names. I'm really bad at sports terminology, so if I mess up some names, please forgive me. But so here we want to know the left-footed players. So we could filter and map across that data. So filtering takes out. So in this example, we're taking out the right-footed players. And then mapping applies a function across all the items that we get. So this gives us back an array of just the one line, messy.
Just say messy.
Just messy. So that would be really great. But Firestore events come in over time. So it would seem like maybe we need something that can handle data events that are happening over time. Luckily, we have that, and it's called an observable. So observables are a data type that really helps you model this information. We use observables from RxJS, but hopefully they'll be added to the JavaScript library. We can't really know that for sure, but there will be, in a language of your choice, some sort of mirror to that. Observables are quite complicated. We actually think you could have an entire talk on observables. And as we're thinking about that, we kind of came up with a metaphor. So when I first learned about them, I was very confused, and this helped me. And so it is sports related, but I think it makes sense if you don't understand sports as well. So the example is that an observable is kind of like a goalie. So you put the goalie on the field, and as the events are happening, those are like shots being taken at the goal. And so an observable catches those shots and then decides to act upon them. So maybe it throws it back. That's a thing, yeah.
Mm-hmm, that's a thing.
And maybe sometimes it kicks it a little bit, also a thing, right? And so it takes an event and decides what to do on it. And so there's a few other things here too. If you knew all the shots at the beginning of a soccer game, football game, that might be kind of boring. So these events happen over time. So maybe one happens at minute 1 and one happens at minute 50. And you don't know what they're going to do, but you know that the goalie is going to catch the ball and act on that.
So we go back to the array example first up, but let's say that we had all the shots up front. You're familiar with filtering and mapping. So we're filtering these shots based on ones kicked by left-footed players, and then we're extracting using map. We're transforming to get the name. So that would give us an array of left-footed shooting players. So observables have very similar syntax. Filtering and mapping is similar, except it acts over time. So if we imagine shots are coming in over time, we're filtering this stream so that we only have shots kicked by left-footed players, and then we're transforming each of those into the string of the player name. So a couple of things here. We're using a $ as the variable naming convention. That's just like a convention in the observable space. That just denotes this is an observable. And then also subscribe. So subscribe's pretty important. So observables are lazy by default. So if we wire up this to connect to some real-time event source, it will only start doing that once we call subscribe. So without subscribe, nothing actually happens. And we'll use that later to our advantage. Yeah, and so here over time, we would get Messi, and then maybe Robin. I'm not going to try and pronounce his first name.
So we think that Firestore and observables make a lot of sense together. So Firestore has a bunch of snapshot data coming in over time. You don't know, maybe you're going to get 100 documents, maybe you're going to get 1,000 documents, and all of that state's going to be given to you over time. And observables are a way of modeling data that comes in over time. So for us, together, they make a lot of sense.
So here's putting this into action with the actual Firestore SDK. So we're listening to the collection items. Observables, we basically just wrap the onSnapshot using this method, using this format here. So we now have snapshots $, that's our observable of snapshots over time. Then we can take either the doc changes or the docs. We're going to use docs here for simplicity. So we're mapping a snapshot. Each snapshot gets converted into the plain array, the state of the world at that point in time. And then we haven't subscribed yet, so here we'll subscribe and we'll just log these out. So an example of this is we have an array of 2 documents, and then at some point someone adds another one. Now we have an array of 3 documents in order. This is the state of the world view.
So each document can be up to 1 megabyte. So for our purposes, we want to limit the amount of information that we're storing and keeping track of in the UI. So we do a few more mappings. So this is interesting. We do an observable map on the doc observable. And then that's actually a list of documents, so we map within there to get only the doc ID and an update time, and we use the update time for animations, which we'll talk about later, and we use the ID to display the data. So we've gone from getting the observable back from Firestore to now an observable of IDs and update times. And that'll look something like this, as you see, just the update time and the ID in an array, or in an observable. And so here, putting it all on the page, we can see we have a little bit of Angular syntactic sugar. That bar async is a way of subscribing, so that handles everything for us. We use Angular. You don't have to. There should be some parallels in whatever framework you want to use. But here, all we do is just loop through this document list data, and that puts everything up on the screen like this. So when we have 500 documents, it'll display that. If we go up to 5,000 documents, we'll get that back as an observable and loop through all of them.
So this works great, works in real time. Well, it doesn't quite work great. So we started entering in a lot of data, and the UI got really, really slow and eventually just unusable. So what's happening here? So the problem is we're just rendering way too much data. So if you imagine that this list on the right-hand side has like roughly 6 nodes in it per document, there's a little arrow, there's some hover things that we do there. So that's like 30,000 nodes. That's way too much. That's crazy. You shouldn't be trying to render all of that.
Yeah. Browser just cannot do that.
Yeah. So we need to restrict that. So first up, we use virtual scroll.
So virtual scroll is a way of limiting what you see on the page. If you're familiar with Recycle View from Android, this is the same concept. So really, we only need and care about 20 documents that we want to see on the screen. So virtual scroll says, OK, what's visible on the screen? And everything else, it handles removing and adding. So we keep track of a master list, which is all of our items. And virtual scroll tells us which of those items is on the screen. So this is really great for Firestore because we start with, if we have only 20 documents visible on the screen, and we have about 6 nodes, HTML DOM nodes for that, that's about 120. So if you have 500 documents on your list, you have about 120 DOM nodes. If you have 5,000 documents on in your list, that gets added somehow, you have 120 DOM nodes, which is a really great performance boost for the UI rendering information. So this is what that looks like in code. We have here, we pass in our docs into our virtual scroll component, and then the virtual scroll component gives us back a list of visible items, and we loop through that to display them on the page.
So here's a little snippet of that in action, scrolling through that central list, and you'll see on the right-hand side in the dev tools, it'll scroll down in a little second, but you'll see that we never go further than the 20 nodes there in the list.
So now we have a way of limiting what we show on the page, but Firestore is still really happy to send us 5,000, 50,000 documents back. And so all of that data going across the wire is a lot for the browser to handle. And also, you probably don't want to be sending all of that. Luckily, Firestore has really great querying capabilities, so we decided to take advantage of those and just recycle our virtual scroll pattern. Sounds about right?
Mm-hmm. Yeah, so we started with this pattern where as we scroll, we just update the query so that the pipe async will unsubscribe and resubscribe if the query changes, the docs $, if that changes. So here's that. So we're using start at and limit of 20 to recreate that query.
So the first time this fires one single scroll, we get a new observable. We tear down the old one, create a new one, and that gives us back items 0 to 20. Okay, we scroll one more document. We get items 1 to 21. One more document, we get 2 to 22. And every time that's happening, we're tearing stuff down, recreating our observable, and just really having some intensive operations. Clearly, that doesn't really make sense. We have a bunch of operations, and maybe like 20 of our documents stay about the same. So we realized that we needed to do something else, some other way to handle this. So we decided to restrict the data using pagination.
Yeah, so we decided to split it up into chunks of roughly 50 items and then do a similar thing with the virtual scroll, but this would create less query thrashing, let's say. So initially we started using limits. What we're using here is order by _name is saying order the documents by ID. Start at 0 or our first ID and then limit by 50. So this seems to work initially, but we run into some issues where users aren't always putting data in at the end of the list. And so if you're deleting from the chunks, they start to overlap or miss data. So for example, if that second chunk is starting at 50 and the first chunk starts deleting items out of it, then the item 50 will bleed into that first chunk. And then vice versa, you'll have an issue where if you're inserting items between the chunks, they won't get captured in the queries. So this wasn't quite enough.
So we decided to use cursors. We really want to make sure that we get those 49.1 and 49.2. So there's a few cursor queries you can do. There's start at and end at. And those are inclusive, so it includes the numbers. And then start after and end after, they exclude the numbers that you pass in. So we found the mix of start after and end at to be really what we were looking for when we're trying to handle this updating list of documents. So we get all of 0 through 49, and we start after 49 for the second chunk and end at 99. So you could add as many 49 points, whatever, as you want, and those will get included in the second chunk. Yeah. So there's one caveat here, is that we had to create an initial query to build the chunks. So that's kind of the drawback of using that approach.
Yeah, so we use an initial limit query of a much larger set, say 100, 300 items, to find those chunk boundaries, and then we create much smaller queries. So putting this together, so on the left here we have the visible scroll area, which informs the set of chunks in the middle there. The chunks can be subscribed or unsubscribed. More than one can be subscribed at any time. And then that basically sets, those changes flow into a master list where some areas are not in real time and some areas are in real time. And then that master list flows into the virtual scroll, which handles cutting out the DOM rendering.
So in code, we create our chunk interface. You can see it has a query, and also it has an end at. So this is how we represent our chunks in the code. Then we create a query on the next slide area. And so we call dv.collection of path. So we're keeping track of the path as we move through the Firestore UI. So if you go in and check it out, there's actually a bunch of sub-collections that we handle really nicely. Out of scope for this talk, but we keep track of the path. So pass that in as a thing we're listening to. We order by the name, so that's the document ID, and we start after the previous chunk's last element, and then we end at this chunk's end at. So that allows us to capture all of those things in a query, and we don't call snapshot or subscribe there. It's just the raw query because we want to do a little bit more to it. Mm-hmm. Yeah. So as you notice, we subscribe here with the new observable. We call snapshot. We still don't just subscribe. Sorry, my bad. We're still not subscribing here, but we just get the documents. So we're ready to subscribe, but we haven't subscribed yet. So that's our query object.
Yeah, so turning on and off chunks is handled via subscribing and unsubscribing. And so the higher level view of that is when we get to a point where we want to turn a chunk on, we use basically this high level query. So the query, take until, is an operator in RxJS or in Observables that essentially says, listen to this or subscribe to this until such time that this scroll data view emits any value. So what is scroll data view? So that's another observable. That's an observable that listens to the scroll position of the document list. It filters out, and it filters those scroll events until the chunk has scrolled out of view. And then take one basically says, I only care about one of these. So I only care about that first point where it is scrolled out of view. And so tying this together into the top query, we're saying, yeah, take all of the real-time updates for this chunk until such time that I've decided the chunk is now scrolled out of view.
So I think that Tim is really underselling how cool this is. This is like the coolest thing we do in the UI, and I'm so, like every time my mind is blown by this. So what's happening is we're setting everything up off of a scroll event. So this scroll event moves in and out of the virtual scroll, and as we're doing that, we're saying, once you get out of view, stop listening to the real-time database. So this allows us to really restrict what we're listening to, so we're not sending a bunch of information across the wire. That's really cool. We're also handling tearing down logic. So as we said at the beginning, tearing down is really important. It'll lead to memory leaks. It leads to bad performance. It's just really, really hard to keep track of everything. We actually, in our code, have some things that we do not unsubscribe from. So it is like really hard to keep track of that, and this logic handles all of that while scrolling the page and keeping track of what's in view. It's amazing. It's like definitely the coolest thing that we do in the UI for sure.
Yeah, and also, so the tearing down is really important as well, because if you have a massive list of documents, they can all be 1 megabyte in size. When we detach from the real-time Firestore listener, that takes those documents out of memory as well. And then also, this is essentially what we're actually doing in the UI. We have a little bit of delay logic on there as well, so that the chunks disable after a timer. But essentially, this is what we're doing. And just imagine doing this with all the tracking and tearing down and unsubscribing. If you were doing this like imperatively, it'd be like 3 times this size.
Definitely 3 times this size. I think before we set this up, there were so many messy things, and then this came in, and I was like, oh my gosh. So, you know, we've taken this massive amount of Firestore, massively scaling database, and figured out how to model it using observables. And we've figured out using Firestore queries how to limit the data that we're showing on the page. But that's not enough. We have to make the experience really delightful and show off the real-time capabilities of Firestore and also be Firebasey, which is important to us. So we figured real-time visualizations would be really, really hard. We were like, we're going to have to spend a few weeks on that. But seemingly, we have our visual changes component, and we use Angular animations here. So every time a value gets added to the DOM, it's going to go green. And every time it's removed, it goes red. And if it's updated or changed, we have a function that compares things.
Yeah, so we just use so in React or Angular, you have some function like this, which is previous props, next props, or previous value, next value. Yeah, so we just basically diff on that value, and then that's how we do the changed animation, which is the orange animation. There's a little bit more that we do here with the fields. So doing a direct strict equals here is not always enough. So if we're comparing complex object types, we do like a shallow or a deep equals to handle the field changes. But this is essentially what we're doing here. So we put that all together, and ho, 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 it's Christmas.
Not yet.
Yeah, so we ended up with this. See if you can figure out what's going on there. It's not quite what we wanted. So
yeah, not the goal.
Yeah. So what's happening here is we're using Angular animations, which detects the elements and the components adding to the DOM to animate and then removing from the DOM, and then the virtual scroll is not playing nicely with that because it is artificially removing and adding things from the DOM at the top and the bottom of the list. So as you scroll, they're both playing around with each other. So we need a way to get around this.
So the way that we do that is we hook back into that scroll event and call it disable animations. And that disable animations waits half a second. And so until you're done scrolling, and then after that, it will reinstate animations. And so that's kind of how we got around the little bit of jank of virtual scroll in our UI.
So then we ended up with an actual working real-time viewer. So here it is.
Yeah, and as you scroll through, you'll see it doesn't update, and then the updates happen a little bit later.
Okay.
So too lazy, didn't read of this talk, is that we think observables are a really great way to model data coming in from Firestore or any streaming data that you're processing via an API in JavaScript, and then take advantage of Firestore's queries to limit what you're getting back, so you're not sending a lot of stuff across the wire. And then finally, take the extra steps to make it real time and make it show up and be delightful for your users.
Cool. Thank you.
Thank you so much.